Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at Chem Advantage.
This is a beautiful experiment where we take some potassium dichromate and add iron 2 to it. The dichromate is this classic yellow-orange, and then the chromium 3 ion is this +3. Chromium is very interesting in terms of changing its number of electrons that it has, and it's even been postulated that this might be a good way to end up storing electricity by this change of electrons. But let's watch this experiment as Miss Lee does it. She has the solution which has been acidified, then gradually adds the iron +2 to it, and we get this beautiful chromate 3. Here's the question that we should be dealing with. What are the charge of the reactants in this balanced reaction? Here I've written the reaction with just its ions that are involved, and you can see we've got our dichromate polyatomic ions all the time, and we have one of them, so we have a charge of -2, and there is just one of them, so I'm not going to bother multiplying by 1. Then we have 6 iron +2s, so we're going to have 6 times 2. I'm not going to use a +2. And then we have 14 +1, so I'm just going to add 14 to this and see what our total number is going to be, 24. So our charge of the reactants is a +24, and that's what we have when we are starting here. When we look at the net ions, or the ion charges. Now, in the actual solution, this +24 is balanced by other ions that are in the solution. So we're not going to have to worry about this having an electric charge, but the ions involved have a charge of +24. Now, what happens when we end up making our products? What are the charges that are involved here? Well, we've got 2 chromates with a +3, so I can say 2 times 3. And then we're going to add to that the 6 iron +3, so I can do 6 times 3. Any negatives? No, the water is neutral. So our answer is going to be 24. Surprise, surprise. Well, that's what happens. When you have a certain charge for reactants, you're going to have the same charge for your products. And this can be a way that you can use to solve problems. We've got a conservation of charge and mass in all of our reactions.